Okay, my name is Hartmut. I'm from Bielefeld in Germany. I studied computer science, electric engineering, and a little bit of biology there. And I've been using OpenStreetMap for a little bit over a decade now. And in my day job, I work as a database support engineer for MariaDB and formerly for MySQL. But that is not related to today's talk at all. So what I'm going to talk about is the Mapnik rendering library and how to use it from Python. So what Mapnik does, it is the rendering library that, for example, renders the map tiles you see on OpenStreetMap. But it can do a lot of other things. So it can process a lot of different input formats, can produce a lot of different graphics formats as output. And it uses specific style information to do so. And as it is a library and not a standalone program, it also needs a little bit of extra wrapper code to really make it do what you want it to do. So first, on the input side, we can read several different map data formats like shapefiles, which is a specific geospatial file format, or we can read geospatial data from different databases, mostly PostGIS, but also the GIS data that MySQL MariaDB can provide, and also what SpatialLite, so the spatial-enabled version of SQLite, can provide. And we can natively use GeoJSON files. And also via plugins, we can read further file formats like the native OpenStreetMap XML format, GP extracts, and via the GDAL library, different raster image formats like satellite images and stuff like that. And on the output side, we can produce PNG bitmap images in high or low color resolution. That's the usual use case for map tiles as you see them on sites like OpenStreetMap and other map sites that use OpenStreetMap data. But we can also produce JPEG, which is not the optimal format, but can give you better compression rates if file size is an issue. We can produce scalable vector graphics that you can, for example, use in Inkscape or other vector drawing programs to post-process the generated maps. Or we can, for printing, produce PDF, or the classic PostScript is also still available. And as styles, so we need style information to specify which input objects from the input data stream should look how in the output image. And there are two ways to do that. One is to really use the Mapnik library functions to define a style information on the go, step by step. That's very flexible, but also takes a lot of effort. So as an alternative, we have a style file format that is a special XML format that is more compact and more easy to use, but not as flexible as if you could decide in your code, depending on certain conditions, which styles to use. But the typical use case is to use XML styles, and there is a rich collection of different styles for OpenStreetMap publicly available. And we can also convert some other map style sheet formats, especially the Kato CSS format, into the XML format that is needed by Mapnik. So OpenStreetMap for some years now actually uses Kato CSS styles, converts these to Mapnik XML on the fly, and then renders the map tiles with that. And as already said, Mapnik is a library. So we need some extra code to tell it what to do. And for that, as it is a C++ library, we have the option to do that directly in C++, but that's complicated and can easily crash. So as an alternative, we have good Python bindings, and that's what I'm mostly going to talk about in the rest of the talk. And there's also now some experimental bindings for PHP 7, but these do not support the full range of Mapnik capabilities yet. And if you want to use Mapnik and Python together, you obviously need Python. It doesn't matter if you want to use Python version 2 or version 3. There are bindings for both. And there are also 2 different Mapnik versions around still. I only used Mapnik 3, the current one, but some Linux distributions may still come with the version 2 libraries. And if you want to add additional stuff to the generated images beyond that what Mapnik renders itself, you also need the Cairo bindings for Python and maybe libraries for S4G and for font handling. That's what the Pango library here is. So on current Ubuntu, this would be the packages that you need. You need the Python 3 Mapnik bindings. If you haven't installed Python 3 or Mapnik yet, these will be installed automatically. And you may need the Pango font handling. You may, if you want to put additional SVG images on top, need the RSVG bindings and the general GTK introspection package to make the other 2 work. So all the Mapnik data sources like shapefiles or database bindings produce a data stream that comes as 4 kinds of different objects. Simple points, 1-dimensional lines, 2-dimensional polygons that cover areas, or predefined raster images. And they may look different in the actual data source, but that's what the input API then provides to the further stages of the library. And inside Mapnik we have 3 main different kinds of objects. That is layers, styles, and symbolizers. And the layer is what a database or a data source provides as data. So if you use a shapefile, it's everything that is in the shapefile. If you use a database, it is what is produced by the actual database query you bind to a layer. And then we have styles. Styles consume everything that is in a layer and decide how to actually display these data items. And we have symbolizers. Symbolizers are the things that actually do the work of painting. So the simplest type we have is the point symbolizer that either just draws a point at a certain position, or it draws a given image that you can specify, like a point of interest icon for shops or for gas stations or whatever you have. Then we have the line symbolizers that draw lines in different styles. So for example, if you want to draw a road, you may want to draw it in yellow and have small black lines at the side to distinguish them from the background. That's what the line symbolizer can do. Then we have the Polygon Symbolizer that draws and fills areas in a given color and style. And we have the raster symbolizer that just puts raster image data from the input side into the output side. And we have some more sophisticated symbolizers, like the marker symbolizer can be repeated if it is used on line or polygon data, whereas the point is just as a fixed position. we have a line pattern symbolizer that is similar to the marker symbolizer when you use it on a line, but with the marker symbolizer, the marker image is always upright, and with the line pattern symbolizer, it follows the direction of the line. So line symbolizer is used, for example, when you want to draw a one-way road which has these little one-way arrows on it. That would draw the line in a certain style and then put little arrow symbols on top. We have text symbolizers to put text on the map. Usually helpful if things have names on the map. We have a special marker symbolizer called shield symbolizer that is used for highway numbers and stuff, where depending on the text in the marker size has to be extended. And it's called shield symbolizers because the highway signs on the US highways look like ancient knight shields. We have polygon pattern symbolizer, that is if you want to fill a polygon not just with a certain color but with a certain repeated pattern. Like on maps you often have forests in green and little tree symbols in there. So you would have one symbol that has the background color and one tree in it, and then it's just repeated to fill the polygon. And we have a building symbolizer that sort of draws pseudo 3D buildings by taking the building height into account. So now let's go to the Python part and start with the simplest example we can have. We just import the Mapnik bindings. We create a map of 600 pixels wide, 300 pixels high, and we render the map to a file. File name Word PNG, format PNG, and obviously there is nothing in it yet. We just get a 300 by 600 pixel image with transparent background. So let's add a little bit to it. First we give the map a background color, steel blue here. Then we define a polygon symbolizer. The only style information we give it is fill all the polygons you see in green. Then we have to set up a style rule that binds to the symbolizer. We have to register the style rule here under the name of countries in the map. And then we define a layer named world, and that has a data source that is a shapefile that contains all borders of all countries in the world. And then we add that layer to the map. We do a zoom all that zooms in on all the data we have on the map so that the map is exactly as large as it has to be to draw all data we specified. And again, we render into a file. And now we see something. So we see all the countries in the world. And we also see the borders, even though I didn't specify any border style. That's actually an artifact, as the polygon symbolizer does anti-aliasing on the borders. So that is what's producing the borders here. And we will turn that off in the next example. So the style rules can also filter on the input data. And now if you want to have a map, a world map that has Germany standing out, we can add, first of all we take the symbolizer from the last example and put the anti-aliasing factor to 0 to get rid of all these border artifacts, which is the rule. So now we create a second symbolizer object and say, okay, this one is going to be filled in red. And we set up a second rule, and this rule gets a filter. So it filters by the expression, by the name, by the field with the name in the input, and the name should be Germany. And then we draw it again, and we have the map now without the border artifacts, but we have Germany standing out in red. So that was the version in doing it in Python only. And let's now look at the XML version. That is much shorter, as all it does is to load the Word XML file here, to zoom in on the data again, and to render into the PNG file. The map XML looks like this. It starts with a map tag, where you can give the background color. We have the polygon style that only fills every country in green. We have the second one with the filter for Germany that fills in red. And we have our layer that uses the style we defined above. It uses the country shapefile again. And obviously, or hopefully, yeah, produces the same result. Now for using symbolizers in detail, I have created two simple GeoJSON files that I will use now. So instead of the shapefile I used for all the borders, I now use example 1 GeoJSON. And I only have a very simple point symbolizer that just puts a simple point PNG image on the point position. And this is the GeoJSON file for this, just containing 2 points. And so we get a map that doesn't really look like a map, but only has 2 points on it. We can do the same for GeoJSON containing a line. This line also has extra property name, which is test street here. Here we use a slightly more complicated symbolizer. So first we need a slightly more complicated rule. So first we use a line symbolizer that just says paint the line in blue and with a stroke width of 3 pixels, of 3 points actually. And then we use a text symbolizer that has placement line, is text should be along the line. It is given a font name, it is given a fill color, and a halo fill. That we will see in the example how that looks like. So this is our simple test street, just a blue line with the black text on it, and the halo is the slight white shadow along the letters, so that they stick a bit more out from the background. So even if the text would be painted on black background, it would still be visible. And then there are the other symbolizers I already mentioned. Described here once again. And then finally, you may want to decorate your map. So you don't only want to have the rendered result, but you also want to have a title on it, a copyright notice on it, or stuff, whatever you can think of. And for this, we can combine the Mapnik bindings and the Cairo bindings in Python. As Mapnik can use 2 different render backends. One is a library called AGG that is only used for high-quality bitmaps. And it can use the Cairo library, both for bitmaps and for the vector formats, so for SVG, PNG, SVG, PDF, and PostScript. And so here we do not give it a file name right away, but we first define a Cairo style first that has the file name. Then we create a Cairo drawing context. Then we set up our map as we did before. But now instead to writing to a file, we render to the Cairo context. And then we can use that context and put extra things in there. Like here, simple rectangle. So the 2 dots are from our GeoJSON map rendered by Mapnik, and the rectangle is from Python Cairo. And we can also use that for putting extra images in our map. Like here are compass rose that just tells us where's the true north on the map. Or we can use the same for text. And so, in summary, we now have a solution that can render us a base map, like here. And we could put a line's title on top. We can put a copyright notice on the bottom. And this special case is a neighborhood map of my area where I live. And it's not very well visible, but there are extra markers here on the map. And these markers have numbers and correspond to the list on the right. So if you look for the nearest Krankenhaus or the nearest hospital, you know it is in square F9. Or if you see the marker here and want to know what it is, if you could see the number in here, it would be a 3. And you could look it up on the index on the right to find what is marker 3. And there is also a JavaScript front end for that. So you can produce this kind of map as PDF yourself on the URL above. And actually this all stems from a solution called Mapnik. That is also a web front end for creating maps, and from which I got all the knowledge for this. And that is used to either print single page large format PDFs with the street index here on the side, or you can also use it using the PDF context in Cairo to produce multi-page PDF maps. Like here are the first pages of a little atlas booklet. So you have a title page, you see which area is on which detail page, and then there are 16 detail pages behind this that form an actually little town atlas. So what I learned working on this is, code-wise, it turned out to be easier than I thought, at least as long as you use XML styles and not the programmatic styles. There's always the devil in the details and in the styles. It never looks like you want to in the first try. It is a very flexible solution if you want to mix map data and custom rendered data, custom image decorations. And unfortunately, what I also found is the documentation of Mapnik and Mapnik Python bindings is not optimal. Okay. Thank you. I also have 2 sample prints in here, but I think we ran out of time, so if you want to see them, we could do that outside. Any quick questions? Yeah. Yes, I left that out because the time slot was too short. I have conversion code for converting pixel coordinates into map coordinates and the other way around using the Mapnik map object. One more, maybe? Okay. Oh, okay. Outside. Cool.